Question 2.1 is about the tangent and the velocity problem. The first thing to remember is the point-slope form of a line. And that is given by y minus y1 is equal to m times x minus x1, where the point is given by, so x1, y1 is a point on the line, and m represents the slope. The second thing to recall is the idea of a secant line. So in geometry, that's a line that intersects the circle in 2 points. And the tangent line just touches the circle at 1 point. We have a similar idea for functions or curves in the plane. Given a function, the graph of a function f, I can choose two values of x These values correspond to points on the graph of the function. We'll call this function f. And the line passing through these points is called the secant line. Okay, it intersects the graph of the function locally in 2 points. I could also draw a line that locally just touches my function in this 1 point, and this is what we'll call the tangent line to the curve. Okay, and here is the tangent line right here. One of our goals will be to find the slope of the tangent line. The slope of the secant line is easy to determine because I have 2 points on the line. So I know that my slope will be given by f of x2 minus f of x1 over x2 minus x1. So that's just the rise over the run. The problem with the tangent line is that I only have 1 point on the line, and so I can't use this formula to determine the slope. What we're going to do is we're going to try to estimate the slope of the tangent line, and the way that we're going to do that is we're going to use slopes of secant lines in order to estimate the slope of the tangent line. Okay, so in this example, we're going to estimate the slope of the tangent line to the curve y equal x squared when x is equal to 1. So that means at the point 1, 1. The basic idea is that we're going to, let's quickly sketch do a sketch of this graph. So it's just a parabola. Okay, and the point 1, 1 occurs right here. And so the idea is I want to estimate the slope of this tangent line. And as I said before, we only have 1 point, so I can't compute the slope of this line. However, what I can do is I can choose another value of x that's close to 1, for instance, 0, and I can use the point on the graph of the parabola that corresponds to x equals 0 in order to create a secant line. So I'm going to do that right now. So there's my secant line. And the secant line passes through 0, 0, and 1, 1. And you can see that the secant line is close to the tangent line, so that the slope of the secant line should be close to the slope of the tangent line. The advantage, though, is that I can calculate the slope of the secant line because I have 2 points. So that's the basic idea.